100 facts about linear motion. 1 to 10. Basics of linear motion. 1. Linear motion is the movement of an object in a straight line. 2. It's also known as rectilinear motion. 3. Speed is the rate at which an object moves. 4. Velocity is speed with direction. 5. Acceleration is the rate of change of velocity. 6. Distance is the total length covered. 7. Displacement is the change in position. 8. A positive velocity indicates movement in one direction, while a negative velocity indicates movement in the opposite direction. 9. Zero acceleration means constant velocity. 10. Constant velocity means constant speed in direction. 11 to 20. Newton's laws and linear motion. 11. Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will remain in motion with constant velocity unless acted upon by an unbalanced force. 12. This law is also known as the law of inertia. 13. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. 14. Mathematically, F equals ma, where F is force, m is mass, and a is acceleration. 15. Newton's third law of motion states that for every action, there is an equal and opposite reaction. 16. The force exerted by one object on another is equal in magnitude and opposite in direction to the force exerted by the second object on the first. 17. The weight of an object is the force of gravity acting on it. 18. The mass of an object is a measure of its resistance to acceleration. 19. The normal force is the force exerted by a surface on an object in contact with it. 20. The frictional force opposes the motion of an object. 21 to 30. Graphs of linear motion. 21. A distance time graph shows the distance traveled by an object over time. 22. The slope of a distance time graph represents the average speed of the object. 23. A velocity time graph shows the velocity of an object over time. 24. The slope of a velocity time graph represents the acceleration of the object. 25. The area under a velocity time graph represents the displacement of the object. 26. A displacement time graph shows the displacement of an object over time. 27. The slope of a displacement time graph represents the average velocity of the object. 28. The area under a displacement time graph does not have a physical meaning. 29. A positive slope on a distance time or displacement time graph indicates motion in one direction, while a negative slope indicates motion in the opposite direction. 30. A horizontal line on a velocity time graph indicates constant velocity. 31 to 40. Equations of linear motion. 31. The four equations of linear motion are v equals u plus at s equals ut plus 1/2 at squared v squared equals u squared plus 2 as s equals u plus v, t, 2. 32. V is the final velocity, u is the initial velocity, a is the acceleration, s is the displacement, and t is the time. 33. These equations can be used to solve problems involving linear motion. 34. The equation v equals u plus at can be used to find the final velocity, initial velocity, acceleration, or time. 35. The equation s equals ut plus 1/2 at squared can be used to find the displacement, initial velocity, acceleration, or time. 36. The equation v squared equals u squared plus 2 as can be used to find the final velocity, initial velocity, acceleration, or displacement. 37. The equation s equals u plus v, t, 2 can be used to find the displacement, initial velocity, final velocity, or time. 38. These equations can be derived from the definition of acceleration and the equations of calculus. 39. These equations assume that the acceleration is constant. 40. If the acceleration is not constant, these equations cannot be used. 41 to 50. Free fall. 41. Free fall is the motion of an object under the influence of gravity only. 42. In free fall, the acceleration of the object is equal to the acceleration due to gravity, which is approximately 9.8 meters per square second on Earth. 43. The equations of linear motion can be used to analyze free fall problems. 44. The time taken for an object to fall from a height h is given by t equals sqrt, 2h per gram. 45. The final velocity of an object that has fallen from a height h is given by v equals sqrt, 2gh. 46. The maximum height reached by an object thrown upward with an initial velocity u is given by h equals u caret 2/2 of a gram. 47. The time taken for an object to reach its maximum height is given by t equals u per gram. 48. The total time taken for an object to reach its maximum height and return to its starting point is given by 2u per gram. 49. The velocity of an object at its maximum height is 0. 50. The acceleration of an object in free fall is constant. 51 to 60. Projectile motion. 51. Projectile motion is the motion of an object thrown into the air with an initial velocity. 52. Projectile motion is a combination of horizontal and vertical motion. 53. The horizontal motion of a projectile is uniform, meaning that the velocity is constant. 54. The vertical motion of a projectile is accelerated, due to the force of gravity. 55. The path of a projectile is a parabola. 56. The range of a projectile is the horizontal distance that it travels before hitting the ground. 57. The maximum height of a projectile is the vertical distance that it reaches before falling back down. 58. The time of flight of a projectile is the time that it spends in the air. 59. The equations of linear motion can be used to analyze projectile motion problems. 60. The range of a projectile can be calculated using the formula r equals u squared sin 2 theta per gram, where u is the initial velocity, theta is the angle of projection, and g is the acceleration due to gravity. 61 to 70. Relative motion. 61. Relative motion is the study of the motion of one object with respect to another. 62. The relative velocity of one object with respect to another is the vector difference between their velocities. 63. If two objects are moving in the same direction, their relative velocity is the difference between their speeds. 64. If two objects are moving in opposite directions, their relative velocity is the sum of their speeds. 65. If two objects are moving at an angle to each other, their relative velocity can be found using vector addition. 66. The relative velocity of an object with respect to the ground is called its ground speed. 67. The relative velocity of an object with respect to the air is called its airspeed. 68. The wind speed is the relative velocity of the air with respect to the ground. 69. The ground speed of an aircraft can be found using the formula Vg equals Va plus Vw, where Vg is the ground speed, Va is the airspeed, and Vw is the wind speed. 70. The course of an aircraft is the direction in which it is flying relative to the ground. 71 to 80. Momentum. 71. Momentum is the product of an object's mass and its velocity. 72. Momentum is a vector quantity, meaning that it has both magnitude and direction. 73. The law of conservation of momentum states that the total momentum of a system of objects remains constant if no external forces act on the system. 74. This law is a consequence of Newton's third law of motion. 75. When two objects collide, their total momentum before the collision is equal to their total momentum after the collision. 76. This is true regardless of whether the collision is elastic or inelastic. 77. In an elastic collision, kinetic energy is conserved. 78. In an inelastic collision, some of the kinetic energy is converted into other forms of energy, such as heat or sound. 79. The momentum of a system of objects can be calculated by adding the momentum of each individual object. 80. The momentum of a system of objects can be used to predict the motion of the objects after a collision. 81 to 90. Circular motion. 81. Circular motion is the motion of an object in a circle. 82. The speed of an object in circular motion is constant. 83. The direction of the velocity of an object in circular motion is constantly changing. 84. The acceleration of an object in circular motion is directed towards the center of the circle. 85. This acceleration is called centripetal acceleration. 86. The magnitude of the centripetal acceleration is given by A equals v squared, r, where v is the speed of the object and r is the radius of the circle. 87. The centripetal force is the force that causes an object to move in a circle. 88. The magnitude of the centripetal force is given by F equals mv squared, r, where m is the mass of the object, v is its speed, and r is the radius of the circle. 89. Examples of circular motion include the motion of the Earth around the Sun, the motion of a car around a curve, and the motion of a Ferris wheel. 90. The period of a circular motion is the time taken for one complete revolution. 91 to 100. Applications of linear motion. 91. Linear motion is used in many. 91 to 100. Applications of linear motion. 91. Linear motion is used in many areas of science, technology, and engineering. 92. In physics, linear motion is used to study the motion of objects, such as projectiles, falling objects, and objects moving in a straight line. 93. In engineering, linear motion is used to design and build machines, such as linear actuators, conveyor belts, and robots. 94. In transportation, linear motion is used to design and build vehicles, such as cars, trains, and airplanes. 95. In manufacturing, linear motion is used to build machines that can move objects in a straight line, such as lathes, milling machines, and drilling machines. 96. In sports, linear motion is used to analyze the performance of athletes, such as runners and swimmers. 97. In medicine, linear motion is used to design and build medical devices, such as X-ray machines and MRI machines. 98. In astronomy, linear motion is used to study the motion of stars, planets, and other celestial objects. 99. In everyday life, linear motion is used in many ways, such as when we walk, run, or drive. 100. Linear motion is a fundamental concept in physics that has many important applications in our daily lives.